Hello friends, welcome to Achieve Abundant Academy. Up to last lecture we have discussed up to question number 4. So we will discuss question number 5 onwards in this particular lecture. Okay, so we are basically discussing the problems on the constraint motion. Okay, so let us start our discussion. Okay, so what is given in the question is that the particle is projected from the inner side of a smooth vertical circle of radius A. Okay, so this is the radius A and the velocity of projection is u. Okay, so what is given in the question is that if u square is less than 5 ag and greater than 2 ag, then the particle will leave the circle before arriving at the highest point and will describe a parabola whose lattice rectum is given by this particular expression. Okay, so this is the lowest point. Okay, here theta is equal to 0. This is the highest point. Here theta is equal to pi, and through center this is the horizontal diameter. Here theta is equal to pi by 2. So somewhere here between the pi by 2 and pi, the particle will leave the circular motion. Okay, so if and at this particular and at various instances there is a reaction R. Okay, that is acting on this ball. Okay, let us say particle. Okay, so the reaction R is acting on the particle. So somewhere between theta is equal to pi by 2 and theta is equal to pi, this particle will leave the circular movement. Okay, so it will not follow this circular path, rather it will leave the circular path and follow a parabolic path like this. Okay, because reaction becomes 0 here. Okay, so the reaction becomes 0 and it will follow a parabolic path. Okay, so let us show that at this particular, let us consider this as angle theta. At angle theta, theta 1, suppose at angle theta 1 the reaction is 0. So let us find out the theta 1. Okay, so at random theta, the reaction R is given by the expression R is equal to mu square upon A minus mg 2 minus 3 cos theta. Okay, suppose at angle theta we have to find the reaction R. Okay, we have to find the reaction R. So this reaction R is given by this particular expression. So let at theta is equal to theta 1, R is equal to 0. So at this particular instance R is equal to 0 and we have considered this as a theta 1. This we have considered as this angle we have considered as theta 1. Okay, so this angle is theta 1. So let us find this. So we have 0. Let us put theta is equal to theta 1 in this particular expression. So mu square upon A minus mg 2 minus 3 cos theta 1. Okay, so we have mu square upon A into 1 upon mg equal to 2 minus 3 cos theta 1. So we have 3 cos theta 1 is equal to 2 minus 3 cos theta 1 is equal to 2 minus u square upon ag. This is equal to 2ag minus u square upon ag. So cos theta 1 is equal to 2ag minus u square upon 3ag. Okay. So now since mu square is greater than 2ag and less than 5ag. So 2ag minus u square will be negative because u square is greater than 2ag. So 2ag minus u square is equal to negative. This means numerator is negative. So cos theta 1 is equal to negative. This means theta 1 will lie between pi by 2 and pi. This means at angle theta is equal to theta 1, the particle will leave the circular fashion. Okay, so the particle will leave the circle and follow the parabolic path. Okay, parabolic path like this. Okay, so this is our parabolic path. So what we have to show that if 2ag is less than u square and u square is less than 5 ag, the particle will leave the circle before. So at angle theta 1, so theta 1 lies between pi by 2 and pi. So at a random theta 1 and theta 1 restriction on the theta 1 is given by um, theta 1 restriction on the theta 1 is pi by 2 to pi. This means before reaching the highest point, particle will leave the circle and follow the parabolic path. Okay, so let us find the latus rectum. Okay, so we have cos theta 1 is equal to 2ag minus u square upon 3ag. So we have cos theta 1 is equal to 2ag minus u square upon 3ag. Okay, so we have the figure like this. Okay, so at angle theta 1, the particle will leave the circular movement and will follow a parabolic path like this. Okay, suppose initial velocity is u and final velocity is v1. Okay, so this angle will be pi minus theta 1. This angle is pi minus theta 1, so then this angle will be pi minus theta 1. Okay, so what will be the latus rectum? So let us recall our discussion on the latus rectum. Okay, so latus rectum is perpendicular drawn from the on the axis of the parabola through the focus. So let us consider this as focus. Okay, so perpendicular drawn on the axis of the parabola. Axis of parabola. Perpendicular. So this is the latus rectum. This is the latus rectum, which is equal to 4 times of A. Okay, so in case of projectile motion, suppose the initial velocity is u at an angle of alpha, the latus rectum is given by 2 upon g into horizontal velocity ka whole square. Horizontal velocity ka whole square. So this is 2 upon g into u cos alpha is the horizontal velocity upon whole square. This is the latus rectum. So let us use this in solving this particular question. Okay, so we have latus rectum is equal to 2 upon g into horizontal velocity is v1, sorry, horizontal velocity is v1 cos of this angle is pi minus theta 1, pi minus theta 1. Okay, horizontal velocity into horizontal velocity ka whole square. So v1 cos pi minus theta 1 ka whole square is equal to 2 upon g into v1 square into minus cos theta 1 whole square. Okay, this is 2 upon g into v1 square into minus cos theta 1 is minus cos theta 1 is equal to u square minus 2ag upon 3ag. This is equal to u square minus 2ag upon 3ag the whole square. So let us find the value of velocity at an angle of theta 1. The velocity is given by v square is equal to u square minus 2ag 1 minus cos theta. Okay, so at angle theta is equal to theta 1, the velocity is v1 square is equal to initial velocity square minus 2ag 1 minus cos theta 1. Okay, so we have v1 square is equal to u square minus 2ag 1 minus cos theta 1 is 2ag minus u square upon 3ag. So v1 square is equal to u square minus 2ag into 3ag minus 2ag. So ag plus u square upon 3ag. This gets cancelled. This is equal to 3u square uh, minus 2ag minus 2u square upon 3 v1 square. Okay, so we have v1 square is equal to u square minus 2ag upon 3. Let us put this in this particular expression. Okay, so what we will have, Latus rectum. So latus rectum is equal to 2 upon g into v1 square is u square minus 2ag upon 3 into this is square, so u square minus 2ag का whole square. Okay, upon 3 3 is 9, 9a square g square. This is equal to latus rectum is equal to 2 into u square minus 2ag. This is 1 or this is 2. So 2 plus 1 is 3 upon 27a square g. Okay, so this is the latus rectum. The particle will leave the circle before arriving at the highest point. This we have already shown because the restriction that is coming on the theta is theta 1 is cos theta 1 is negative because u square, the restriction on u square is given by u square is greater than 2ag and less than 5ag. Okay, so this numerator term will be negative. Cos theta 1 is negative. So cos theta 1 is negative. This means theta lies between pi by 2 and pi. This means before reaching the highest point, this is the highest point. Before reaching the highest point, the particle will leave the circle and rather follow the parabolic path. And in case of the parabolic path, latus rectum is given by 2 upon g into horizontal velocity ka whole square. Whole square. So in this particular expression, from here, from this particular point at theta 1, the parabolic path starts. So at this particular theta is equal to theta 1, the velocity is given by v1. Okay, so initial velocity is v1. So horizontal velocity is v1 cos alpha. So v1 cos alpha we have placed here. So this is basically horizontal velocity. Okay, horizontal velocity ka whole square 2 upon g. So we have based on the further calculation, the latus rectum is given by this particular expression. Okay, so let us solve the next question. What is given in question number 6? In question number 6, a heavy particle is attached to a fixed point by a fine string of length A. The particle is projected horizontally from the lowest point. The heavy particle is attached to a fixed point. Okay, particle is projected horizontally with a from the lowest point with a velocity. The u is equal to root under ag 2 plus 3 root 3 upon 2. This is the initial velocity. Prove that the string would first become slack when inclined to the upward vertical at an angle of 30 degree. Okay, so let us find the angle theta 1 where the tension becomes 0. This means when the tension becomes 0, the string will get slacked. Okay, so what is given in the question? Prove that the string would first become slack when inclined to the upward vertical at an angle 30 and will become tight again when horizontal. So at this particular point at an angle theta 1, the string will becomes slacked. Okay, that is tension is 0. So what is the expression for the tension at a random theta is given by tension is equal to mu square upon a minus mg 2 minus 3 cos theta. This is the expression at random theta, the value of the tension at random theta. Okay, so let at theta is equal to theta 1, the string becomes slacked. Okay, that is tension is equal to 0 at theta is equal to theta 1. Let us place theta is equal to theta 1. So tension is equal to m upon a into initial velocity is this one. So this is ag 2 plus 3 root 3 upon 2. Okay, mu square upon a minus mg 2 minus 3 cos theta 1. Okay, so we have this is 0. Tension is equal to 0. So we have m upon a this gets cancelled. This is mg 0 is equal to mg 2 plus 3 root 3 upon 2 minus 2 plus 3 cos theta 1. Okay, so 2 gets cancelled. Mg gets cancelled. So we have 3 root 3 upon 2 is equal to 3 minus of 3 cos theta 1. 3 gets cancelled. This means cos theta 1 is equal to minus root 3 upon 2. This is equal to cos of pi minus 30 degree. Cos 30 is root 3 by 2. So cos of pi minus 30 is minus root 3 by 2. This means theta 1 is equal to pi minus 30 degree is equal to 150 degree. So this is 150 degree. So this angle will be, this is 150. So this angle will be 180 minus 150. So this is equal to 30 degree. So at an angle of, let us draw this again. At an angle of 150 degree, tension is equal to 0. That is, string becomes slacked. Okay. So the tension from the vertical will be 30 degree. Okay, so this is being asked in the question. Prove that the string would first become slack when inclined to the upward vertical at an angle of 30 degree. So this is the angle from the upward vertical. Okay, and will become tight again when horizontal. So what? So from this particular point, let us consider this point as B and this point as A. So from this particular point B onwards, it will follow a parabolic path. Okay, so as per the demand of this question, so this will hit again at the horizontal diameter on the opposite side. So this will hit the horizontal diameter at this particular point. This is the parabol. This is the parabolic path. Parabolic path. Okay. So let us consider the velocity v1 here. Okay, and the initial velocity is u. So let us find the v1. So this will hit the horizontal diameter at this particular point and will become tight again. So from this particular, let us consider this as C. So from point C onwards, it will follow the circular path like this. So reaction is not 0 here, r not equal to 0, r not equal to 0. But at this particular point, r is equal to 0 because from point B onwards, it will leave the circular path and follow the parabolic path. And hit from point B, it will hit at point C. And point C onwards, it will again follow the circular path. Okay. So what will be the coordinate of this point? So the coordinate of this point will satisfy the equation of trajectory. Okay. So let us draw this again. R is equal to 0. This angle is theta is equal to 150 degree. Okay. The initial velocity is u is equal to ag 2 plus 3 root 3 upon 2 pi 100. Okay. So let us find the velocity v1 when the projectile motion starts. So this angle is 30. So this angle will also be 30 degree. Okay. So let us find the final velocity. Final velocity at theta is equal to 150 degree. Okay, so we have v1 square is equal to u1 square. The ag 2 plus 3 root 3 upon 2 minus 2 ag. What is the final velocity? V square is equal to u square minus 2 ag 1 minus cos theta. 2 ag 1 minus cos of theta. So cos theta is 150 degree. Okay, so we have this as v1 square is equal to ag comma 2 plus 3 root 3 upon 2 minus 2. This is cos 50 is minus root 3 upon 2. So this will be plus minus 2. This will be 1 plus. Let us replace this 1 plus root 3 by 2. Okay, cos 150 is minus of cos 30. So this will be minus 2 minus root 3. Okay, AG we have taken comma. So this is 2. 2 times root 3 upon 2. This gets cancelled. So we have this as v1 square is equal to AG times root 3 upon 2. 3 minus 2 is 1. So root 3 upon 2 AG. Okay, so v1 square is equal to v1 square is equal to AG root 3 upon 2. So let us find the equation of trajectory. So our trajectory will like this. So this is the horizontal diameter. So it will start the parabolic path from this particular point and will hit the horizontal diameter at this particular point. Okay, and now let us consider this as B and this as C. So from point C onwards, it will follow the circular path like this. So it will become tight again because R not equal to 0, and here R not equal to 0, R not equal to 0, and but here R is equal to 0. Okay, because at angle of 150 degree it will becomes slacked. Okay, so because reaction is 0 here. Okay, so let us find the coordinate of this particular point. So this coordinate of this will be, so this is 30, so this is 60. So this will be a cos 60 to a by 2. Okay, so this whole distance will be a by 2. Okay, a by 2 plus a, 3a by 2. Okay, and this distance will be, this is a of, this is 30. Okay, so this is a cos 30. A cos 30 will be a root 3 upon 2. So this is 3a by 2 of minus, because we are taking in negative y direction. So 3a by 2 and minus root 3a upon 2 is the coordinate. So let us find the equation of trajectory. So we have v1 square is equal to ag root 3 upon 2. So we have equation of trajectory as y is equal to x tan of, this is 30, so this will also be 30, x tan 30 minus gx square upon 2 v1 square cos square, so this is 30, this is 30, cos square 30 degree. So we have y is equal to x upon root 3 minus gx square upon 2 into v1 square is this 2 ag root 3 upon 2 into cos 30 is root 3 upon 2 ka whole square, so 3 upon 4. So this gets cancelled, this is cancelled. So we have y is equal to x upon root 3 minus 4x square upon 4x square upon 3 root 3 of sorry, 3 root 3 of a. Okay. So we have the equation of trajectory as x tan theta, x tan alpha minus gx square upon 2u square cos square alpha. So alpha is 30 degree and v1 square is this one, ag root 3 upon 2. So let us put here, this is 4 upon 3 root 3. So now let us put the value of x coordinate. So this is the expression for the trajectory. So if it hits this particular point, then the coordinate of this particular point will satisfy the equation of trajectory. So on putting the value as x is equal to 3a upon 2, we must get y is equal to minus root 3a upon 2. So let us put x is equal to 3 upon 2. Y at x is equal to 3a upon 2 is given by 1 upon root 3 into 3a upon 2 minus 4 upon 3 root 3a into x square. So 9a square upon 4. This gets cancelled. So we have root 3a upon 2 minus 3 gets cancelled. So this is root under 3a is equal to minus root 3a upon 2. Y is equal to. So this is same as the y coordinate. This means the coordinate of point C is satisfying the equation of trajectory. Hence, this particle will hit the point C at the horizontal diameter. Okay, and after point C, it will become tight again, because henceforth the reaction is not zero. Okay. एक पूछा है ना, prove that the string would become slack when inclined to the upward vertical at 30 degree. This we have already shown. Okay, now because we have arrived at the angle of theta 1 as 150 degree, this means the angle from the vertical is 30 degree. Okay, उसके बाद बोल रहा है becomes slack when inclined to the upward vertical at angle of 30 will become tight again when the horizontal. Tight again when horizontal. So this is at this particular point onwards it will become tight again because henceforth the um, reaction is not zero. Okay. So let us solve question number 7. Okay, a heavy particle hanging vertically from a fixed point by a light inextensible cord of length L is struck by a horizontal blow which imparts it a velocity 2 root under GL. Prove that the cord becomes slack when particle has risen to a height 2L upon 3 above the fixed point. Okay, so what is given in the question is that heavy particle hanging vertically from a fixed point. Okay, the cord length is L. It is struck by a horizontal blow. The initial velocity is 2 root under GL. Okay. Prove that the cord becomes slack when particle has risen to a height above the fixed point. Okay, so let us find this angle theta 1. So, tension is given by mu square upon a minus mg 2 minus 3 cos theta 1. Okay, so we have, sorry, cos theta. So let at theta is equal to theta 1, tension is equal to 0. So 0 is equal to m into m upon a into u square. This is 4gl. Okay, u square is equal to 4 into gl. Okay, minus mg 2 minus 3 cos theta 1. Okay, so we have this, sorry, mu square upon a. At a we will have L because the radius is L. Okay, so this will be L. Here a is equal to L. Okay, so this gets cancelled. So 0 is equal to 4 mg minus 2 mg plus 3 mg cos theta 1. Okay, so we have 0 is equal to 2 mg plus 3 mg cos theta 1. This gets cancelled. So cos theta 1 is equal to minus 2 upon 3. Okay, so this angle will be pi minus theta 1. Okay, so this is L. So this vertical height will be, so this is pi minus theta 1, this is pi minus theta 1. So this is L cos of pi minus theta 1. This is minus of L cos theta 1. This distance. Okay, so let us find this. Let us put this point as A, this point as B, and this point as L, B, C. Okay, so BC is equal to L of cos pi minus theta 1. This is equal to minus L cos theta 1. BC is equal to the minus L into cos theta 1 is minus 2 by 3, minus 2 upon 3. So this is 2L upon 3. BC is equal to. Okay, so this is asked in question. Prove that the cord becomes slack when the particle is risen to a height 2L upon 3 above the fixed point. This is the fixed point. Okay, so this angle is theta 1. So from the fixed point, this height is 2L upon 3. So at this particular point, it will follow the parabolic path. Okay, because tension is 0 here. So at theta is equal to theta 1, tension is equal to 0. And this point B is at a height of 12 upon 3 from the fixed point. So this point is fixed. So from the fixed point, this is at an angle of 12 upon 3. Okay, so now let us solve part 2 of this question. So we have cos theta 1 is equal to minus 2 upon 3. Highest point of the parabola, subsequently height of the highest point. v1. Let us consider the velocity at point B as v1 square. Okay, v1. The velocity at point B is v1, and initial velocity is u is equal to 2 root under gl. The final velocity is v1 square is equal to u square minus 2gl. Okay, 1 minus cos theta 1. v1 square is equal to u square. This is 4gl. 4gl minus 2gl. 2gl. Sorry. 1 cos theta 1 is 2 by 3. So this is plus 2 by 3. So this is v1 square is equal to 4gl minus 2gl. 2gl into 5 upon 3. This is 4 3 are 12 minus 10. Matlab v1 square is equal to 12 minus 10. This is 2gl upon 3. Okay, so v1 square is equal to given by 2gl upon 3. Okay, this one v1 is equal to root under 2gl upon 3. Okay, so this is pi minus theta 1. This angle will be, so this angle will be pi minus theta 1. So let us find the height. So we have h dash is equal to, let us consider the height of the, what we have shown, what we have seen in the previous set of lecture is that highest point h, highest point of the projectile is given by h is equal to, suppose the initial velocity is u at an angle of alpha. So h is equal to u square cos square alpha, sorry, u square sin square alpha, u square sin square alpha upon 2g. Okay, so here let us consider this the path of the trajectory. Okay, so the highest point will be like this. This is the highest point. Let us draw this again. So at angle theta 1, it ceases to have a circular path. Okay, so it will follow a parabolic path like this. So this is the axis. So this is our highest point. Okay, this is the highest point. Suppose this is P, this is Q. So PQ is equal to H dash. So, and this is the angle of projection of the projectile. So this is V1 is equal to root under 2GL upon 3. Okay, so angle of projection is this is pi minus theta 1, angle of projection. So in case of in projectile we have initial velocity, that is v1 is equal to 2gl upon 3 root under, this is whole, and angle of projection alpha is equal to pi minus theta 1. समझ में आ रहा है? So let us solve this. So we have height h is equal to u square, so 2gl upon 3 u square sin square alpha pi minus theta upon 2g. So h dash is equal to l upon 3 into sin square theta 1. Okay, so we have cos theta 1 is equal to minus 2 by 3. So this we can write h dash is equal to l by 3, 1 minus cos square theta 1. This is equal to l upon 3 into 1 minus 2 by 3 ka whole square. This is equal to l by 3 into 1 minus 2 to the 4 upon 9. 4 upon 9. So this is equal to 5l upon 27. This is the height h dash. Okay. So let us find the height from the from the fixed point. So this height is what becomes like when the particle has risen to 12 upon 3 above the fixed point. So this is 12 upon 3. So net height क्या हो जाएगा? 12 upon 3 plus 5L upon 27. So height of the highest point. H is equal to H dash. H dash is this particular distance H dash, and let us add this one 2L upon 3. So H dash plus 2L upon 3. H is equal to 5L upon 27 plus 2L upon 3. Let us multiply 9 up and down. So this is equal to 9 to the 18 plus 5. 8 5 13 23. 23L upon 27. This is H. Okay. So height of the highest point is given by 23L upon 27. Okay. So we will discuss further questions in next particular lecture. Thank you.